that awkward pause. Everyone, welcome to the Carolina Weather Group. Obviously, I'm controlling the technical side tonight, and I'm not Shay Gibson, so it's going to probably go a little rough. But anyway, welcome to our little weather get-together tonight. This is the 231st episode, and tonight we have Dana Griffin on with us from the National Weather Service in Huntsville, Alabama. We're talking about the Geostationary Lightning Mapper, the all-new tools that we get to use with Ghost 16 and Ghost 17. And so we're happy to have Dana on with us tonight from the Huntsville office there in Alabama. And Dana is a first-time guest, so we'll allow him to introduce himself here in just a little bit. But before we do that, a couple of housekeeping rules tonight. This is a live broadcast, so if you are watching tonight on Facebook Live or YouTube or Periscope, you feel free to interact with us tonight. You can do that via Twitter at Carolina WX Group, or you can send a comment on the Facebook Live, and we will monitor that. And if you have any questions after the show, or maybe you're listening on our podcast a couple of days from now, we'll allow Dana to share maybe some bits and pieces, maybe some websites or something that you can get more information about the Lightning Mapper. So with that, we have, I think, all of our panelists here except James tonight. So almost a full panel. We'll bring in everyone, and let's start out in Oklahoma tonight. We have Miss Ashley with us. Ashley, you're on a little work retreat this week, right?
Yeah, I think you wanted to say Texas, didn't you?
Yeah, I was going to say Oklahoma. Texas. I've messed everything else up today, so go ahead.
No. So I'm sitting here in Norman, Oklahoma, and I'm doing some amazing research. So I don't know if anybody has heard about it, but it's facets, and it's through NSSL. So we're looking at the future of severe weather warnings. So they're calling in a bunch of emergency managers to test the future and see if this new plume approach will actually help us make decisions better. So I'm really excited because not everybody gets to take a look at this data.
It is an exciting time, Ashley. I know our friend Brad Panovich has been in that class that you've been in, and I heard from him it was a great class. So hopefully next week you'll be able to share all of your experiences from what you've experienced there so far in Norman. So we thank Ashley for joining us tonight, even though she is kind of out of office this week. So we appreciate that, Ashley. Let's go to the Memphis, Tennessee area, and we'll bring in Eric tonight. Eric, how's things going there in the Memphis area?
It's hot. It's very hot. Summer showed up, and just a comment, I've seen the presentations on facets before. It is fascinating. I just love that stuff. So make sure that you pay attention to that. The temperature climbed to almost 90 degrees here today in Memphis, and in my 7-day forecast, I have nothing below 89. People are already complaining about the heat. It is May 9th. So we're well ahead of the seasonal calendar. As far as the heat goes, but at least the humidity is not too bad. So we'll take what we've got and hopefully get a little relief at some point.
Eric, don't you remember 4 weeks ago we were shivering and cold, and I mean
we had the third coldest April on record in Memphis, and literally when the calendar flipped to May, the temperature shot up, and we've been in the mid 80s since the 5th, and so. Just 1 degree of 80 before this month. Wow. Literally flipped.
Fascinating. Well, we appreciate that, Eric. And you're going to send that warmth to us here in the Carolinas here in the next few days. Let's bring in, Shay's not in Charleston. We'll bring Shay in just a little bit. But let's bring in Jared. Jared's how are things going in the Charleston area?
Well, we've had a nice few days, very nice and seasonable, 81, 82. In some parts, 83 has been the official high. Just got the climate report up here. Today we got to 84, but we're going to just turn the heat up a little bit more. And first 90s of the year coming probably this weekend, maybe as early as tomorrow, but we'll see how that turns out. But yeah, still really dry. We'll be interested to see what the drought monitor does for us again. We had a nice little rain come through a couple weeks ago, and then hasn't really had much since. So we'll see how that turns out, because we still could use the rain. Fortunately, it looks like we're going to get some next week, but we're getting into that time of year where we're starting to see some of those 20% chances roll into the forecast every afternoon, and pretty much point click put it on autopilot at this point. Just say 91 20% chance of rain and call it a day. Back to you, Scotty.
Thank you for that, Jared. I would say this is where we go to Jordan, but Jordan is on vacation this week, so we let him stay on vacation. We didn't bring him in. So let's bring in a guy that you haven't seen in a long time because he's been battling finals and schoolwork and all that. Let's bring in Peter tonight. Peter, how's things going for you?
Oh, very good. Now the finals are over. I can finally go back to weathering again. I didn't follow too much last couple weeks, but April's been pretty below normal. We were staying in the 50s and 60s with cloudy and rain, and it was just pretty sloppy the whole month. But now the last 2 weeks or so, we've been in the 80s, and I think we did hit 90 one day last week, but 70s and 80s mostly, and that's the way we're staying through the next couple of weeks. Now, the biggest thing has been the pollen. That is all over the place because we haven't had rain in a long while, and it's not looking like we're getting any significant rain probably for the next week or so. Maybe Sunday and maybe tomorrow, if even that, but not looking like a high chance. So pollen is going to be a problem, and I'll show you a video for Tweet of the Week coming up. I sent it to you guys yesterday. We have a major pollen problem here, and you'll see that coming up.
That was a really cool video. Well, let's go down before we go to Shay. Let's bring in Ricky Matthews tonight. Ricky, how's things going there in Eastern Tennessee?
Nice tease, Peter. You should work in television or something. That was impressive. Things are going. We had a few storms over the weekend. Boy, Saturday had some golf ball sized hail, some $50 sized hail. It was a fun day when the Weather Service starts putting tornado possible tags and warnings, and you're the only one there at the station. It was an eventful day, needless to say, but we have kind of calmed down since then. Some run-of-the-mill, typical storms pop up in the afternoon, but in the 80s, enjoying our warmth. I was thinking back to earlier, Scotty, when we were back in January, I want to say it was, when we were like at 5 degrees and all of our lakes had frozen over. For some reason, that just bounced back into my head today, and that was a horrible time. And this is a much better time now than those 20s and 30s and teens were.
See, this is why Ricky and I are really good friends, because we much prefer the warm weather over the cold weather. So,
exactly.
All right, well, let's bring in Shay Gibson. Shay also on assignment this week. He is, I think he's coming home now, but he was in Orlando, Florida for the Weather Flow Conference. So, Shay, if you can hear us, how's things going? How were things in Florida?
It was hot down there. I mean, they had their first 90s of the year when I got there today. It was 92 degrees, and so they're just starting to get their heat turned up. And yeah, the meeting was great this year. All of our sky and air units, our smart weather stations, are going out to all the original backers, and then we have another tier of stations going out in the near future. So if you're familiar with those, you can go to our WeatherFlow site to check them out. But they're really, really neat smart home weather stations. Really, really cool stuff. Really good updates from the company and exciting things to come. But pretty hot down there. Quick update on the tropics, because our hurricane season starts in the Atlantic Basin June 1st, which is just 3 weeks. And our Atlantic Ocean temps are warming up. The Gulf of Mexico temps are warming up. So this time of the year, we start to look for any little anomalies or spin-ups over these warmer waters. And when one happened just a few days ago, the NHC had their first blip on radar for 2018, and it was a 0% chance for development, but it was a decent-looking low. And a lot of folks were asking, is this going to be a sign of an active season? The answer is no. I mean, it's way too early to even tell, and the NHC predictions haven't come out yet, not quite yet. I think it's going to be pretty soon, the next few days. With that said, everything is looking pretty good right now, pretty stable overall. We still have frontal boundaries coming off the coastline, which is good. It pulls anything away. And we'll just continue to watch. But right now, there's nothing to worry about out there, and there's no signs that we're going to have a super active season. We're all on kind of guard for it. The good news is that the Pacific is starting to warm up. And so we're still in La Nina watch, but we're going to be sliding towards a neutral phase, which means we may see a little less activity in the Atlantic Basin as a result of that. But that has yet to be determined. Like I said, still too early, but just keep an eye out. Keep tuned into your local Mets and NHC from time to time to see if there's anything that happens a little bit early in May. But other than that, we're good to go. Back to you, Scotty.
Thank you, Shay. So basically you're telling me not to freak out over the GFS post that I saw earlier today about this monstrous hurricane.
Well, if it's 384, then yeah, you need to evacuate. Okay, get that gigantic grocery cart, empty out the stores, and 384 hours. Okay, that's what you need.
We go from 384-hour snowstorms to 384-hour hurricanes. So that's how it works in the weather world, right, guys and girls? Yeah, it does. So, all right.
I was kidding, by the way. So don't take me literally on that, everyone.
All right, Eric, save us. I'm going to toss it to you.
I was just getting my hurricane kit ready. I was in my mind. I was thinking about what I need up for the first landfall on the Gulf Coast. So we're going to get into the real business here, because otherwise this show is going to completely fall apart. So I'm glad to have introduced to you Dana Griffin from the National Weather Service in Huntsville, Alabama. For some reason, to this point, I had not met Dana, and I don't know how that's possible, because we graduated from the same school, I think a year apart, maybe. I'll have him tell us when he graduated from the University of Memphis, then Memphis State. But we were introduced by a common friend in Rick Smith we're familiar with out at the Weather Service in Norman, when we were at the Southeast Severe Weather Symposium back about a month or so ago down at Mississippi State. Got to meet him and spend some time, and he did a really great job at the presentation that he gave down there on the GOES Lightning Mapper, part of the new GOES 16 satellite. And so welcome Dana onto the show, and say hello, and give us a little bit of a background on kind of how you got into weather and what you've been doing up to this point.
Hey, good evening, Eric. It's a pleasure to be with all of y'all. It's a nice first time to be on the show. As Eric said, my background, I originally graduated from Memphis State, which is now the University of Memphis. Rick Smith and I were at Memphis State together, so that's how far back I go, having known Rick Smith. I then went on to Mississippi State and got my master's degree. And then a couple of years after that, was fortunate enough to get into the National Weather Service. Started my career actually up in National Weather Service headquarters versus starting off in a field office like a lot of people do. Was hired about what was in the Office of Meteorology and spent really part-time between Silver Spring or headquarters and then what was where INSEP was at the we used to be the Hydrometeorological Prediction Center, HPC, down in Camp Springs. So got some forecasting experience done at HPC and was also part of the AWIPS program office and program management, and part of the deployment for the AWIPS, the original AWIPS design that was deployed to the field. This would be dating back all the way back to like 1998, 1999. So after spending about a year and a half around the Washington, D.C. area, I was fortunate enough to get a forecaster job at the New Orleans Baton Rouge Forecast Office in Slidell, and spent about between 7 and 8 years there, between 99 and 2007. That did include going through Hurricane Katrina. In fact, before I'd ever gone to the Gulf Coast, I lived in Memphis most of my life, so we were used to hurricanes, coming up, as far as, obviously losing strength as a remnant low and such, and still affecting us in much of the Southeast, but never having experienced really any type of hurricane activity or anything of that nature when I first got the job in Slidell. The first real storm I experienced was Allison. Allison is real famous, if you remember, I think back from 99 and the devastation it brought to Houston. And until Harvey got its name last year, that was probably one of the most devastating storms that hit Houston. The remnants of the Allison ended up moving eastward across the western and central Gulf Coast regions, slammed us pretty good in southeast Louisiana and the Mississippi Gulf Coast. And that was literally probably my first experience with any type of tropical system, and that was a decaying tropical storm, of all things. Little did we know, or little did I know, about between 4 and 5 years later, I'd set the stage for the 2005 hurricane season and going through Katrina. I haven't spoken a whole lot about that, but what was interesting is actually I did give a presentation about that at Mississippi State, I believe right after I got to the Huntsville office in 2008. It's one of the few times I've spoke about it. So, but that was definitely an experience. So I I definitely have some sympathy and some shout outs to those that are dealing that have to deal with hurricane forecaster and service in an area that's when you're in a strike prone area for any type of tropical activity. In any case, I've been at the Huntsville office since 2007. That's where I currently am, serving as a forecaster. So, and like Eric said, we met at Mississippi State just this past March at the last severe storm symposium that they had. So I think Rick had told me there was somebody else that had graduated from Memphis that came after us. That Rick said he knew you, Eric, but for some reason, like you said, I never got a chance to meet you, and so it was nice finally get the chance to meet somebody. I've met quite a few people from Mississippi State actually that's here in the Weather Service and working in the broadcast area and other parts of the Met community. But it's nice to actually see somebody from Memphis. You can't say there's too many of us around here. So it's nice to be with y'all.
Very true. Very true. So your topic of your presentations you did at Mississippi State was on the GLM, or the Global Lightning Mapper. So where do your interests come from that kind of got you going that direction? I guess there in Huntsville, there's a lot of different opportunities I know in the Huntsville area to do that sort of work. So
right. Yeah, we one of the really outstanding things about this office and about this location, obviously this area is very, very highly associated with NASA. A lot of the rocket design and the rocket history that started here. Well, that includes the Marshall Space Flight Center. And there's actually what's called, I'll show this in the presentation. We are kind of co-located somewhat and do a lot of work, kind of partner up with the short-term prediction, operational research, and transition team. That's part of the Marshall Space Flight Center, and which is obviously associated with NASA. And really, they have been doing a lot of work in total lightning analysis and prediction really since the office's inception in 2002 to 2003. So really coming here, it was kind of a spin up process of learning a lot of this that had to deal with total lightning and learning about a lot of the different partnerships and a lot of the different kind of the different applications and such that's associated with NASA sport and such. So the Geostationary Lightning Mapper is just one part. It's just one avenue of the GOES East, or what was the GOES 16. Now it's the GOES East satellite package. And fortunate enough with NASA sport, there's a couple of really good contacts that I've gotten to be friends with that are one of them is kind of like the Geostationary Lightning Map contact or person who's kind of the authority, or if you will, with GOES East or GOES 16, and that's kind of where my interest kind of started kind of peaking a little bit, and that's where I thought I might be able to deliver some kind of presentation at Mississippi State, kind of expanding off this. Kind of one of our partners here at this office, he works part-time for us with the Weather Service. The other part, he's affiliated with NASA Sport. He did a presentation there at Mississippi State last year just on the Total Lightning Network that's associated with North Alabama, the Marshall Space Flight Center. And again, I'll kind of allude to that really briefly in the presentation. But again, he kind of gave that presentation last year at Mississippi State. So I thought this year maybe I could zero in that a little bit more on the Geostationary Lightning Mapper as part of kind of this new satellite system, this new technology and such that we're going to have. And it's going to become more and more available as it becomes more and more operational.
Excellent. Well, I think what we'll do is I know you've got the presentation to give us and kind of talk through some of those points. So I think we'll go ahead and do that, let you go through those, and then we'll open it back up afterwards for folks that have questions here. And we'll be monitoring social media channels and so forth affiliated with Carolina Weather Group. So if you guys are listening out there and have any questions, feel free to toss them in, and we'll be watching for those as well. So I'll turn it over to you to go through that, Dana.
Okay, so I think, is this where I need to share my screen to start the presentation up, or?
Yes.
Okay, I can do that. All right, so.
And if you could maybe maximize that, there you go. That'll work.
All right. Does everybody have that?
Yeah, it looks great.
Okay. Well, like Eric said, this was the presentation that I did at Mississippi State this past March. One thing I want to say that's going to be a little bit different than what Eric heard at Mississippi State is in between March, kind of the end of March and now, that I'll highlight on just a little bit in this presentation is that we are one of the test sites. We're one of the beta test sites for receiving the Geostationary Lightning Mapper, or GLM data or observations. And we have actually started receiving those observations in our operational systems. So before I put this presentation together, that had not yet been activated, or switch had been turned on. So I'll be able to kind of make reference to that kind of really quick of what we've been seeing here within the last few weeks as that switch has been turned on, kind of versus to what I said just about a couple of months ago at Mississippi State. Presentation's not that long. I wasn't given obviously a whole lot of time at Mississippi State, so I'll try to go through this pretty quick, and then obviously try to see if I can entertain any questions that you might have afterwards, or I can certainly point you in the right direction if there's something that I can't answer. So let's get started. What exactly is the Geostationary Lightning Mapper? It's a single channel near infrared optical transient detector. As I was talking about, that total lightning, it measures total lightning. And what do I mean by that? Total lightning is a sum of in-cloud, cloud-to-cloud, and cloud-to-ground lightning. Basically, all three of your primary lightning sources over the Americas and adjacent oceanic regions has a pretty much a uniform spatial resolution, approximately 10 kilometers. That's an average. It really varies between 9 and 14 kilometers, but 10 kilometers is a pretty good average. And obviously, it is the first operational lightning mapper flown in orbit as part of the GOES-R, what was, of course, originally the GOES-16 satellite package. So this is where I'll be able to add a little bit to what we're seeing now versus what I said at Mississippi State a couple of months ago. Where is the status of the GLM right now to full operational mode? The GLM stood at provisional status, provisional being that one step away from operational. Some of the issues that they had with some of the preliminary GLM observations were some severe geolocation errors and noise with the data, and also trying to look at some of the large spatial extent flash data being incorrectly chopped, coarse, what have you. Some of that has been fixed, and we are now starting to see that data, like I said, in our observation or our operational systems, I should say. One of the things I can tell you is some of the data that we're seeing initially is still pretty coarse, but it's and they were having some issues with some latency issues as far as like exactly when we were receiving these observations versus like what the current time is. In other words, there might be a 30 to 45 minute lag time in some cases, especially during the overnight hours. A lot of those errors or some of those issues have now been fixed just within the last couple of weeks. So even as I'm saying this, as I'm showing you some of this, they're still working on this and trying to make improvements and getting it ready for operational status. That's one of the benefits for us being a beta test site here in Huntsville. So, and again, the data that's in the GLM, basically it's called flash extent data, and that's similar to other total lightning mapping arrays that I'll briefly hint at here, and I'll show you what I mean by flash extent data. So let's look at some of these early examples of some of the GLM observations or data. They were originally grouped into what's called event densities. Some of the early images and such, in fact, some of the early images that you may see on a couple of these slides I have are actually some of the they're kind of the event driven images, event density images, if you will, of kind of with the flash centroid points on top of it. They eventually broke those down into like group centroid densities, kind of combining the events, and then eventually they even broke that further into the flash centroid densities data, which is considered to be probably more high quality, probably better better return signal for the polarity and such. And that's very similar to what we see just in our local total lightning networks and such. So again, we've kind of been seeing this data for quite a few years in other networks, but again, the GLM, that's how they've kind of broken this data down. And what we're seeing now in our operational systems is that flash extent data, that imagery, etc. So how does the GLM compare with other available ground networks? Kind of just in this image real quick, you got a radar image right there in the top left. The two bottom images, I should say, those are our more common lightning detection networks. You got the Vaisala network and the Earth network's total lightning detection. Kind of on the bottom, on that top right, you've got the GLM kind of event density, again, with that flash centroid data on top of it. That's, again, just giving you an example of what the GLM observation or data is going to look like in comparison just for what our current ground truth data or networks are. One of the things you can really emphasize or look at right away with the GLM data is you're able to really focus in on those stronger updraft cores, stronger storms, pulse storms, whatever the case may be, etc. So that's just, again, that's kind of a good snapshot look of what the GLM data is going to look like, again, compared with radar and other ground truth networks that we've used in the past. As I mentioned, here in Huntsville, now for quite a few years, they've had what's called the North Alabama Lightning Mapping Array, which has basically been North Alabama's version of the total lightning network. Again, total lightning being that sum of lightning flashes in cloud, cloud to cloud, cloud to ground. That's been part of the office's research and observation network since the office's inception in 2003. And the reason I'm mentioning this is a lot of this total lightning networks with North Alabama and even some other local total lightning networks, a lot of these have been done through NASA, Marshall Space Flight Center, and Sport. A lot of those are working closely with us and with a couple of other local offices and such that had these total lightning mappers. That's what served as a conceptual model or proxy for what's now going to be in the Geostationary Lightning Mapper. So that's just kind of what I'm showing you, a little bit of brief history of what we had here in the Huntsville area, North Alabama, for the last several years. So what can we do with the GLM observations in the total lightning network? Certainly it's going to help us in severe weather operations. You certainly would not use the GLM data alone just to help you identify and locate severe and tornado warnings, but it can be an excellent tool to use alongside radar reflectivity and other types of radar data and signatures. What's really probably one of the biggest advantages of GLM data, the advantage of the total lightning data as well, is it's really identifying the updraft core, updraft strength, and just new and regenerating updrafts, etc., with storms. So it can assist with flash and aerial flood warnings, again, because it's showing you that training effect or just that regeneration effect of the updraft and the cores. One thing that I've also noticed, and we've certainly seen here in Huntsville, is it aids in just if we have to do airport weather warnings or other type of local watches, warnings, etc., possibly in the aviation community or others. Again, it's just giving you that a little bit of increased notice, whatever, of that polarity in these storms, within that updraft, whatever the case may be, before you actually see maybe one of the older lightning networks that would actually show a flash or a centroid or something like that. It certainly is really good at just enhancing your situational awareness capabilities as well. And again, convective thunderstorm initiation, showing you where those new updraft, where those new cores are developing. And again, so what I'm talking about, of emphasizing just that. You can look at these two images, and it really kind of helps you pinpoint or locate where are the strongest cores or updrafts, where are they located, where are they building, and it serves as an additional resource when our other current networks, if they should go down or fail, of course. So let's just take a look at a couple applications that we can do with that. One of the first applications, and I'm kind of familiar with this, just coming from the central Gulf Coast area, and this would have been great to have back then, is when you're monitoring convection offshore, even the near shore, offshore waters. This gives you a good idea of just showing you really just what the storm intensity, what the storm makeup, and just the makeup of the convection over those waters look like, especially in data sparse regions where radars may not be able to reach, where the networks are current lightning networks. Again, data may either be course, may be delayed, whatever the case may be. This is just giving you some really just a new tool that kind of helps you show what's that convection looking like over these data sparse regions, such as coastal, nearshore, offshore waters, etc. What's increasing building, what's the nature of it, etc. Again, I've already mentioned this. Here's just a couple examples of it that we can talk about: enhanced situational awareness. And what do I mean about situational awareness? I know the guy, my friend that I talked to over sport, wanted me to really emphasize this. They're talking about lightning safety. That's one of the things they're really, that's really one of the biggest points with the GLM observations is data. Is just enhancing and trying to increase the lightning safety, just for everyone, for the customer base, for us, the customer base, the public, etc. So again, it's been able to show you just those rapidly developing updrafts, the spatial extent of the way the polarity in these storms and the data, the reflectivity data, etc. looks like. And it, like I was talking about, the image on the right, it's just this little bit of the improved aviation forecasting. I don't know if you can really see it, but just kind of that little bit of imagery that the GLM is picking up is showing you some polarity in a couple of some increasing thunderstorm updrafts or cells there right around the Muscle Shoals Airport in Northwest Alabama. That provided about a 5 to 10 minute lead time prior to really any cloud to ground strike or anything that would have been detected by one of our older lightning networks that we use right now. So let's just continue. Convective monitoring, obviously, probably one of the biggest reasons that we have it, and one of the biggest uses we're gonna have with this data. Not just that it's picking up some of the stronger cores and such that you're going to see, the stronger updrafting cores in a lot of these storms, but within this one circle that kind of got highlighted on these images, if you noticed in the far southeast kind of bottom right corner of that circle, in this bottom left imagery, the GLM data is really picking up on some increased polarity right there. And if you go to the top right, the reflectivity, look at that. Again, look at the reflectivity data in relation. The reflectivity data is it's not very well developed. It's kind of poor, kind of weak, etc. That's an indication those could be some building. That could be some building cells, building storms, whatever the case may be. Can just kind of give you, again, a little bit better situational awareness, maybe help you focus on, zero in on a little bit better of some new areas, new developing areas, etc. On top of just being able to help you identify just the strongest updrafting cores. Here's just another quick example. First thing within the circle, you can certainly see the two really strong cores, probably indicative of a couple of severe thunderstorms. But note in the top left image, it's actually picking up a little bit of polarity right there, kind of on the far northeastern half of the Florida there, and really that's just looking like just some very light rain, light showers. So again, indicative of that could be there's just some polarity right there, some a threat for some lightning activity. Could be that you could have some increased convection that could be developing in that part, that region of Florida. Just the GLM is just going to be able to kind of help you again just to identify some of these areas. So finally, let's look at kind of how we would use the GLM data in warning operations. We've got a couple of pretty good cells, pretty good thunderstorms right here. Kind of you can see on the radar reflectivity image there in the middle The top middle, if you look at the bottom middle, kind of the correlation coefficient image, you certainly got a couple of kind of hail signatures, hail cores that's being identified. Look at your GLM data though on the top left. Right now, it's not showing it. I mean, it's certainly indicating it's pinpointing the areas where the updraft of the cores are, but it's not really. It hasn't really strengthened, or what it's indicating, as you're going to see here, is that these two cells are strengthening. But what it's really going to zero in on is look at the northern cell. Again, you can look at the radar reflectivity, you look at the correlation coefficient or the CC data, still got those two Hell signatures, Hell spikes. But what the GLM data is showing is you've definitely got a strengthening your ability and updraft with that northern cell. The southern cell, on the other hand, it's not, it's not doing a whole lot. In other words, it's remaining fairly stagnant. If you're a warning operator, a monitor, whatever the case may be, a user, that's just some extra data, extra observations, what have you, that helps you focus on, wait a minute, that northern cell is not done strengthening yet. And that's even going to be made further with this next image right here. Now the GLM data is really pulsed up on that northern cell. And in fact, on the CC data there, in the bottom middle image, the Hell spike is really kind of really well shown now, versus look at that southern cell. Again, never really continued to strengthen, just kind of remained fairly stagnant for the most part. That was consistent with what the GLM data was showing. So again, the GLM data is able to show that strengthening updraft, that strengthening core with these two cells, and how it was reflected, how it was overall reflected in the radar data, etc. So finally, this is just one area that I wanted you to be able to see. This web address that I have right here. This was provided by Marshall Space Flight Center. This is a way of looking at the GLM data right now, and this is especially helpful for us before we were able to get it into our observational systems, even as a beta test site. Oftentimes I'm sitting there looking at the data. This is the only way that I could see it, or I knew that I was looking at the most up to the minute or the most current data. And there's several different ways you can manipulate the display. Kind of that top left is the main display. You've got a menu choice on the left, and certainly you just kind of go through that menu choice, and you can select different ways to display the data, overlay the data, like reflectivity or satellite data, overlaid with GLM data. And I'm kind of giving you an example there in the bottom left. And I think this next image right here, yeah, there's reflect or satellite data, I should say, overlaid with the GLM data. This is actually the GLM 30-minute hazard data with the GOES East IR satellite image. One thing Jeffrey Stana wanted me to point out in this 30-minute hazard product, and there's some of this research that's still, research that's still going on, that's still being improved with the GLM, first outlined by Chris Schultz and some of his partners that he worked with, Journal of Operational Meteorology, and Jeffrey Stano and some of his partners will be coming out with additional research on this data and this product to be used coming out later this spring. And the data viewer, and kind of like I was talking about, it's an ongoing lightning safety project between local emergency managers and NASA, Marshall Space Flight Center, and sport. Just a good way, again, of just them being able to kind of enhance or show that lightning safety with the enhanced situational awareness. So that's it. That's all I've got. The two references I've got right here, Dr. Jeffrey Stano. He is really the expert person on the GLM on the NASA sports side. And Christopher White is kind of our sport liaison here with the National Weather Service Huntsville. Both of those two great guys were instrumental in helping me put this presentation together. So with that, I am done. I can stop sharing and go back to the main screen, or I can take some questions right now. Just tell me how y'all want me to progress.
Yeah, definitely. I think I'm going to start off the question session. I know you mentioned at the end of your presentation the importance of this data to emergency managers, and that's very important to me because I am one. So I've got a few questions involving that. When all of this stuff becomes developed, operational, do you think emergency managers will be able to have easy access to this data? Are they going to have to dig deep on certain sites, or is it going to be fairly easy for them to look at and then make decisions?
Well, hopefully this, like I said, this one web address right here, this is just one of the tools that I know that NASA Sport is working with right now, and they're working directly with some of our local emergency managers. And really, the data it's very, I mean, you can see right here from the images, really easy to see, really easy to manipulate. And I think really more, and to answer your question, I think overall, I think as the GLM becomes more operational, or kind of we build toward it becoming operational, you're going to see several additional sites, probably where you've already got access to GOES East data. They'll eventually be able to incorporate that GLM data. Again, this is just one viewer, and that Marshall Space Flight Center has been working with directly. But there certainly is going to be others that's going to be coming out with a host of where the GOES East data and such is going to be made available. So I know that the people over at NASA Sport can probably answer that a lot better than I can, since they're looking at this and working with local EMs a lot more. But again, all of this is going to be building as the GLM data becomes operational, which we're not quite there yet, but at least we can see the data. This is just one way of looking at it.
Right. Okay. That sounds excellent. My next question is, a lot of EMs are always looking for precise solutions. So they kind of have a hard time understanding that a lot of our data and our methodology isn't ever 100% certain. So emergency managers who look at this data are going to want to make specific calls, especially if they have city events that they're in charge of, any event action plans they've written for that event and are sitting in the command center for. Would this data be able to provide them assistance in making decisions to start storm shelter plans for these festivals and events that they're in charge of?
Let me tell you this. This is what we're seeing, at least in our operational systems right now. We can see the data up to 1 minute intervals, 1 minute updates. Now, if you want to overlay that with a satellite or radar data, then you're kind of fixing your time stamping whatever the latest images of whether the satellite, radar, etc. But we are, at least as far as our operational side as a beta test site, we're able to see the data in 1 minute intervals. Whether that 1 minute data is going to be made available, if the latency is going to be that quick, or the updates are going to be that fast, I'm not 100% sure. However, I imagine that the data already with the GOES East, I think we're talking 5 minutes or less sometimes when they're in rapid scan mode and such. So chances are emergency managers are going to be able to look at this data, look at different data sources, and it's going to be about as close to real time, I think, as we've seen, as we've got. It's certainly going to be quicker than some of the current lightning networks. Again, the Vaisala, the Earth's networks, total lightning data, etc. Kind of, again, where you could have a delay as much as 15, 20 minutes plus, with that data being plotted and such. I think this is really gonna have an improvement on showing just how quick you might have some lightning or potential lightning building into an area, and hopefully it's just going to make the decision. It's going to make the decision for these key players like emergency managers easier and quicker.
Quick add on to that. I want to ask, you said 1 minute updates, but for lightning, is there going to be a faster sample rate in between minutes? Would there be seconds available that you'd be able to see something? 30 seconds to a minute means a lot with lightning strikes in certain areas. So is that something that is possible in between those intervals?
It could very well be. I'm not 100% sure. I just know that on our systems, we're seeing it at 1 minute, literally at 1 minute intervals, with the latency of my goodness, probably not even 5 minutes. I can tell you this, like I was telling you a couple of weeks ago, when we first started, they first flipped the switch and we were getting the data. Overnight, the latency was 30, 45 minutes, sometimes even longer than 45 minutes. And I looked at the data and I went, this is just not even usable. When you're talking about something that's that late, or you're looking at an image and the image is that old, with the lightning data, they implemented a switch, they implemented an improvement to where when the latency gets longer than 15 minutes, basically the server resets, the switch resets. So as of right now, 1 minute is about the fastest that I know that we're getting it, that we're seeing it. Whether it's going to be faster than that or something like that, that's probably a good question for the NASA Sport folks.
Yeah, and if I could just jump in, I had one more comment about what you were saying about paying for data versus free data. When this becomes available, if you guys could push this out to EMs, they would really appreciate it, because I've met EMs that are contracting and paying big money to private companies to do things that the Weather Service does. So I think any local government and EM would appreciate knowing that this is on the table and potentially free, instead of paying like Earth Networks. Because for instance, we have Earth Networks right now through the fire department, and they had it prior to me arriving. And one reason is lightning data. So if this is a big game changer, then maybe we don't spend that money on that and we spend it on something else.
Right. And please, and like I said, please, write this website down. I can certainly provide this later, and I can certainly get some additional information on this data viewer, the Geo viewer, etc. I can talk with Jeffrey and see if he can maybe provide a little bit of information or something like that. But yeah, that's exactly that's the whole point of what NASA Sport is trying to work toward, and that's why they're working with a lot of our local EMs on that.
Excellent. Well, that's all the questions I had.
Dana, question from me. This is Ricky. First off, excellent presentation. Lots of great information in there, so thank you so much for that. Have you guys used this at all for QLCS tornadoes or QLCS events?
We haven't, to the best of my knowledge. As far as in our area, we haven't had anything yet to test it on. We've seen the data overlaid on, let's say, for example, the storms that affected the plains and into the Midwest and such last week. We were doing some overlays and such on the data, and that's where I referred to the latency and such, and I'm like, God, some of this is ridiculous. And that's also kind of where I made the comment. I'm looking at some of the data and I'm like, this is really, the resolution is kind of coarse and such. In other words, I've still got this image up, and if you look at that kind of middle image, it's kind of zeroing in there on the group and the flash data and the imagery. The data that we were looking at was really, it was even more coarse. The resolution really not even that fine with a lot of these storms and such that were out west. However, I will say this though, you really kind of had to search for it, to be honest with you. But when you did have a stronger cell or a stronger updrafter core, the resolution did get a lot better. But you really had to kind of zoom in on it, and you kind of, it's just one of those, we're looking at, depending on the scale and such, and the latency. You're just, it's a little difficult to look at, and to be honest with you, we're learning it. That's the part of being a beta test site, is we're just learning the best way to look at, examine, even analyze the data, etc. So we haven't had, to answer your question, we haven't had exactly an example or a case yet where we've seen this with anything that's affected us. We've only had, I think the last severe weather event we had, QLCS, was like the 1st of April, that produced a lot of widespread wind damage. So we didn't have access to the data. But I tell you what will be good with this, not just QLCS, as we're getting into, everybody talking about, we're getting into the summer season and such, is pulse storms. Pulse storms, they, of course, they're just given their general name. They can happen. So so quickly, they're so sporadic, and when you're able to look at those and key in on just rapidly developing updrafts and cores, hopefully that's something the GLM is really going to be able to zero in, or just get us that extra set of observations and data. So that would be something interesting to kind of look at if we're getting into the summer season. You know, maybe it's something that's going to be good for helping us identify potential downbursts or microbursts. You know, we'll see.
I know in the past, you know, there's been talk about the Weather Service setting some type of criteria for lightning alerts or something, you know, lightning warning or something like that with these density products, to where it kind of creates a statistical number instead of just like a number of strikes. Is that something that could be looked at in the future?
Well, again, you go back to a lot of these density products and such, and really in the early days of before the implementation of the GLM, really what we were looking at just with our own local total lightning network, we would look at, you know, event densities and the group centroid densities, data and imagery and such, and oftentimes it's like, you know, which one is providing a better sampling of the polarity of the updraft, the core, just whatever the case may be. I think, you know, now they've realized it was just within the last couple of years they implemented, this is with our total lightning network, they implemented that flash centroid density that really is supposed to be an improvement and a better reflection or a better representation of that data polarity, etc. And that's what I think they've used basically as the proxy for what the GLM is going to be in the operational mode. Now, of course, you know, the early examples of the GLM, they're looking at all three of the data sets, but as far as what they're going to make this as far as operational mode, they're looking at that flash centroid density, because that's the one that's going to be, I think, the better representative. Hopefully the most accurate, but certainly the best representative.
I think one comment I'd make on the, I'm sorry, Shay, did you need to go ahead?
Oh, yeah, I was going to ask one more question, but I mean, you can go ahead. I'll go right after you.
Okay. And one comment I make, noted at the very beginning of your presentation, and I've heard this before also, that the spatial resolution of about 10 kilometers on this, I kind of see a use for, there's certainly a lot of good uses for the GLM, and I can see if you're especially doing, you know, decision support for an event or something like that, kind of like the way Ashley was discussing before, that there's probably a good use for this in combination with the other lightning networks that provide you a little bit higher spatial resolution. And, you know, the difference between lightning strike 3 miles away and a lightning strike 5 miles away, when you're talking about, you know, people outdoors at an event, makes a big difference. So you definitely could use both of them in combination, maybe, just to be able to see, you know, what is the trends on the storm using the GLM, and then get your individual strike type of data out.
Right, that's the key point. Again, our current lightning networks are basically they're indicating, you know, they're indicating already that flash centroid, that flash point. Whereas what we've seen with the total lightning networks and the GLM data, this is GLM data in our observations. This is going to indicate potential lightning, increasing polarity, etc., to where you've got something that, even if with your total lightning networks are completely clear, it's showing you something that's building, and of course, it may strengthen into something, or it's just going to give you just something that's just going to be a better tool just to help you be that much more situational aware. But like I said, hopefully it's going to provide you that advanced notice, even if it's just 5 to 10 minutes.
Okay, so my question is, and this might be a little bit out in left field right now, but I want to hear your thoughts on this. What do you think the machine learning process is going to be for the future of GLM? Do you ever think that we will actually get numerical predictions, including lightning strikes, especially, and I know I bring up urban heat islands quite a bit for superheated areas where storms are known to sort of blow up in convection. Do you ever see lightning starting to appear in numerical predictions based on GLM readings and findings?
It could. I think a lot of that's probably better probably better answered by the NASA sport folks. I think a lot of this, depending on how much of this observational data goes into the modeling, I think will probably play some key role into that. And I think now, of course, what we're looking at right now is way in its infancy. And as you know, but we've had some past experience, obviously, within our own total lightning networks. Now, can we apply a number or something to that? No, we haven't been able to do that right now. But then again, I'm not saying that it's been looked at, or it's either been thought about and been modeled or something like that. That's where, I mean, is that something that potentially they can do? It's possible. I mean, but again, that's just, you're getting a lot into the modeling and the research side of it, and a lot of this, of course, a lot of it is still in its infancy, but it's come a long way. I mean, if we're seeing it in our observation systems, our operational systems now, and our observations and such, then we're able to look at the data and such. But like I said, we're just a beta test site, so we've still got a little ways to go.
I should learn to unmute myself on the microphone. Well, Dana, we appreciate all that great information tonight. We'll definitely repost this show for our followers who may not been able to join tonight. But if they want to get more information on this, where would you direct them? Maybe just some of those casual weather junkies who like all things weather. Is there a specific website or anything that you could direct them to? And then if they have any more questions, where would they go?
They can certainly, they're welcome to email me, dana.griffin@noaa.gov. But also, simply, Google and NASA Sport, Marshall Space Flight Center. NASA Sport is, they've got a lot of research and a lot of different applications and products and such. A lot of this deals with lightning, but there's also some other applications and such that they're using. And I mean, really look at that, investigate that. I think that will really probably can at least put you in the right direction. So, but like I said, if you have any specific questions or something like that, you want to email me. And if I can't point you in the right direction, at least I got a couple of really good contacts that I know I can probably get some pretty good information from.
Awesome. Well, Dana, we appreciate that presentation. I'll echo what Ricky said. It was a great presentation, and we appreciate you coming here on the Carolina Weather Group, and we have an open invitation. Any other time you'd like to come hang out with us, we'd certainly welcome that.
Sure. Appreciate that. I had a good time.
Awesome. Well, hang around if you want to. We're going to quickly transition into our tweets of the week before we close out this week's show. I know Peter has had a tease for you all, so I guess we should let Peter go first with his tweet of the week.
Sure, why not? So this was taped by Jennifer Henderson in South Jersey the other day. Her husband was doing some kind of yard work, I guess, or something. And just take a look here what happened. This is really interesting. I thought it was fake when I first saw this. I thought it was like special effects, but it isn't. It's totally real. Check this out. He hits the tree, and look at all the pollen falling off the trees there. So that tells you how bad it is over here. We really need some rain, and allergy sufferers are not very happy because this has been really, really bad this year because of the late blooming and all the cool temperatures we've had. Everything's blooming at once. So, yeah, that's the situation here.
What I want to know is just who thinks, hey, I've got a backhoe. I'm going to go running into some trees.
Yeah, I don't know what's going on here, but
I think Frank Zappa would be happy. One way or the other, you're getting the yellow snow.
Yeah.
Oh, man. Yeah, I hope he had some eye drops or something after that. All right, I see. Let's see. Ricky's got his pulled up. So, Ricky, I'll let you go.
All right, this is from Dr. Rick Knabb. I thought it was kind of neat. Hurricane season is coming up, and I can vouch for a lot of these living in a hurricane zone for much of my life. Top 5 power-dependent hurricane supplies. First off, cash. Second, solar-power USB chargers. Those are nice. Gas, number one thing you need if you want to get out of town. Propane grill and extra filled tank. I can't describe to you how nice it is to have a propane grill, especially with a side burner after a storm. Best thing you'll ever invest in if you live in a hurricane area. And offsite computer data backups. I thought this one was interesting because, a lot of people back up their photos and stuff on like flash drives. problem is they leave it at their house. And so if your house gets destroyed and your computer gets destroyed, well, chances are that flash drive gets destroyed too. So if you have Amazon Prime, you know, you can back up a lot of photos on there. Google Photos lets you back up some stuff. So especially those important photos, you know, that you don't want to lose, always a good idea to maybe back them up online.
I saw that list too, Ricky, and I was real interested by the solar-powered USB charger for your cell phone.
Yeah, I've got one. It's I forget who makes it, but it's a little teeny, you know, fold-out pad, and it does work. You know, solar sometimes can be a finicky thing, but it does work pretty well. Now they make battery packs that are so heavy and so big, you know, that are really nice. But you think about it, if you're in an area that got really badly hit by a hurricane, i.e. Puerto Rico, and you don't have power for weeks, months afterwards, it could really come in handy.
Definitely so. Well, thank you for that, Ricky. Let's go over to Jared. Jared's got his pulled up. So, Jared, I'll let you go ahead.
Yeah, so kind of continuing on the hurricane theme, you know, it is Hurricane Preparedness Week this week. So a lot of the Weather Ready Nation ambassadors have been tweeting about ways to get prepared. And Dr. Nab, that's a fantastic list, put that way. This is another one that it seems like this is a new graphic this year, and I really like this because it's talking about discussing, it comes from the National Weather Service, and it's talking about delivering the right message during, leading up to, during, and after a hurricane, and talking about some of the communications best practices that have evolved over the last, you know, 5-10 years. And I just thought this is really good, you know, pointing out, you know, emphasizing the dangers of each hazard, you know, getting beyond the wind, talking about the storm surge, the water, inland flooding, communicating impacts versus categories, for example, and focusing on beyond the cone. You know, again, you know, we learned, you know, a lot of people got a very harsh lesson from that here in Charleston from Irma, when the cone had it going into the Gulf, but yet we were still getting onshore flow, third highest tide on record, and a lot of flooding rain. And so that was good. Using the official National Hurricane Center forecast, only sharing reliable sources, obviously very important. You know, despite, you know, 384-hour, you know, focanes get great clicks, but that's not really great weather information. And highlighting the hazards that continue after a storm passes. It's so easy to move on, you know, after it goes. But, you know, as Ricky said, you want to be prepared. You want to have, and you want to be, you know, cognizant of the fact that, you know, storm is not just a point in time. The effects will last for weeks, months, and potentially longer, as several places are experiencing right now. So I thought this was really good. This is good advice for, you know, those of us who might be in media, those of us who might be in, you know, just talking about the weather, talking about weather to other people, and a good way to get, you know, to get some good practices out there for everybody to understand what they're sharing, because that is important.
That's all good.
Scotty, I got a request. I'm driving, but I was going to ask Jared if he would get onto see my Twitter, the one I posted with the radar imaging of the jets flying off the coastline, and I can give a brief on that one.
I am getting that for you now, Shay. Please stand by.
Look at this tag team work out of Charleston, South Carolina.
Yeah, man. Yeah. So, you know, springtime seems to be sort of a time when we see an uptick in military jet exercises offshore. And that particular day, I know the winds were going to be kind of veering northeast, and then from the east, and then eventually over from the southeast. And when you get a southeast flow, your sound propagation, it has a lower surface property, so you end up getting a lot more sound from these jets into the coastline. So Jared has my picture up, and basically just some chaff signatures on radar, about 40 plus miles offshore. There was a few more a little bit closer in. The jets that were out there were, I think, F-21 former Israeli jets. They were just practicing with F-18s. We got a little bit more detail in on that one, so we actually know what kind of jets they were. But the bottom line is, you know, this is the kind of thing that we look for. If you hear sonic booms along the coastline this time of the year, it's not necessarily an earthquake or a tremor, even though it could be. Usually, if you feel a boom and then things shake, then you're probably dealing with a sonic boom from a jet. Whereas if it's the opposite, if it's shaking and then you hear a boom, sometimes that could be a tremor, but we don't get many of those, and they're definitely not those. What are those things used to be called? They call them the something cannons. There's another name for them. Seneca guns, yes, and Seneca from New York. I don't know where that whole thing came from. We actually had somebody come on and talk about it, and it was Stephen Jamais from the College of Charleston, and he didn't understand why it was called that. But either way, don't be alarmed if you hear sonic booms. A lot of times it's just military training offshore. As you can see here, we can track it on radar. We can get various signatures to prove it. So interesting stuff.
Thank you for that, Shay and Jared. Thank you for the assist. Let's go to Ashley. She has hers pulled up, and then we'll go to Eric.
Yeah, so I'm sticking with the whole hurricane preparedness theme. So I just found this graphic from New Orleans, NWS, and it is titled, "No name doesn't mean no threat." And this is so important because I see it also with EMs, but the public as well. Just because you don't have a category 3 or a category 4 or 5 or a named storm doesn't mean that you might not have dangerous weather. And the New Orleans office was highlighting an example of just an average low pressure system that had the resources of tropical moisture to drop 10 plus inches. And if you drop 10 plus inches over any area, you're probably going to have flooding. So remember going into tropical season that just because it's not a high end category doesn't mean that you're not going to have impacts. You still might have high flooding or anything like that. So it's really important to hone in on the forecast characteristics of the storm, not the category.
All right. Thank you for that, Ashley. Good information there. And let's go to Eric. Eric?
All right, and this is staying back to the lightning theme. I saw this come across in the last couple of days. The Weather Channel posted this data from the Vizsla network, and it is a 5-year conglomeration, I guess, of stroke density, lightning stroke density globally. And this is basically showing nearly 9 billion lightning strikes over a 5-year period. And it's very interesting to pick out where those little hot spots are, what areas get the most lightning worldwide, and what areas see very, very little. One of the things I found kind of interesting, and I've heard in the past, is that Florida is the lightning capital of the world. But if you look closely at this data, there's some others out there who would lay claim to the same thing, not least of which is the central Gulf Coast. I see quite a bit of lightning there from north of Ashley's area over towards the New Orleans area. That's appears to be a little bit more than even they get in Florida, and then a lot of other hot spots around the world too. So very interesting. Where do the thunderstorms occur worldwide? And this is a very good way to show that.
That is some good information. I'm gonna have to look at that tweet. Good find there, Eric. All right. Let me see. Let me get mine up right quick. Bear with me for just a moment, please. All right, here we go. Can you guys see mine?
Yes.
All right, so this is basically the most active week severe weather-wise in all of the Weather Forecast Office areas. This is the peak of severe thunderstorm warnings or tornado warnings. This is from Daryl Hersman. And again, this is just kind of showing you the peak here for the Carolinas. It looks like July is the main time for all of North Carolina. All of the weather offices that serve North Carolina. Over in Ricky's area, July 4th, and I know that makes him pull his hair out during the 4th of July festivities. And then if you look down into the Columbia area, back towards Atlanta, towards Birmingham, you have 1 week earlier, the June 27th week. But again, as you can see, for much of the Southeast, it's anywhere between the last week of June to the second week of July with the highest amount of either tornado or severe thunderstorm warnings. And if you look out in the Midwest, Oklahoma, Texas, places like that, it's early May or late April, and hence that's why it's kind of a tornado season out there. But I thought that was really good. I love these maps right here. So again, this is kind of a recap of when the most active weather week is for each forecast office served by the National Weather Service. All right, so that's that. Let's go quickly to the schedule here. Let me pull that up. And next week we have actually what Ricky and Jared were talking about. We're going to be talking about preparing for the storm. Cheryl Nelson's going to be joining us. She's going to be letting us know what we need to do to get ready for the hurricane season and tornadoes, flash flooding, all that kind of stuff. Cheryl's going to be with us for that. On the 23rd, we're going to be talking about, it just changed. Good job, Peter. After that, we're going to be talking about lightning with Dr. Eric Bruning from Texas Tech. And then May 30th, we don't have a show scheduled yet. So if you have a topic or a guest you would like for us to bring on the show, please feel free to do that. And then as I look into June, we're almost full through June with Alan Sills from Mobile, Alabama. We're going to be talking about earthquakes as well as a hurricane season preview with Dr. Phil Klotzbach from Colorado State. So that's kind of a look at what's going on here in the next several weeks for the Carolina Weather Group. As always, as I said, if you have any guests or topics you would love for us to talk about, send them our way, and we'll do our best to reach out and get those folks on the show. And for everyone here at the Carolina Weather Group, we hope you have a great rest of the week. Enjoy the warm weather, but stay cool out there, and we'll see you back here next Wednesday night for another episode of the Carolina Weather Group.